Hi, and welcome to Lesson 3, Line Segments and Step Functions. The learning intention for today is that students will understand the purpose of graphs involving line segments and step functions. You'll know you've been successful if you can make decisions about what type of graph to use and can solve worded problems using these different types of graphs. Again, these types of graphs being line segments and step functions. So just a brief outline of what we're going to be talking about today. There are three types of graphs that we're going to look at. We'll do an example of each one. The first one we call a line segment graph, basically because it is multiple different line segments. You'll recall what those are from Lesson 1, all connected together. A step function, this is something that's a little bit new. It's called a step function because it looks like a set of steps or stairs. It's a series of horizontal lines, and we'll see where that's useful. And a scatter plot, which you should all be very familiar with from our previous unit. A scatter plot is a number of disconnected points. We're going to start today by talking about line segment graphs. So here are some of the key features. First of all, the graph is linear, it's a straight line, but the gradient changes partway through. So it's not completely straight in the same way the entire time. It's two or more pieces or segments that are connected together. Might look a little something like this. Both parts of the graph are straight lines, but they have different rates of change or different gradients. Some common examples of this, first of all, charging an hourly rate, where maybe after a certain amount of time, the hourly rate changes. We start paying overtime, for example, if you've worked more than 8 hours in a day. Or a percentage changes after a certain value. This is very common in a couple of places, in tax and in commission. You might pay a certain percent tax on the first $10,000 that you earn, but then as you move up, as you earn more money, on any subsequent money you make, you're going to be paying more tax on that. So to see this in action, I encourage you to check out worked example number 1 to construct and analyze a line segment graph, and then come back here once again when you're finished. The second type of graph that we're going to look at today is a step function. A step function, as I said earlier, it's a little bit weird. Some of the key features are that the y value will stay the same for a little while, and then it will jump or step to another value. So it's not nearly as smooth as a line or a line segment function that we've seen so far. It is composed of a bunch of horizontal line segments. Again, it looks like it's a set of stairs or steps. Something like this. So I've got the line, the function moves across here, and then it jumps. Goes across and then jumps. Across and then jumps up again, and it would continue on, presumably, that way. What's really important here is that at the end of each line segment, there's going to be an open circle and a closed circle. The one exception might be the first line segment. Maybe not. I think this bears mentioning. So, except maybe the first segment. And the reason for that is, well, we have to understand what these open circles and closed circles mean. So an open circle means the value is not included, and a closed circle means the value is included. We'll have a little look here at this part. You'll notice that at this x value here of, say, 0.5, it seems like I'm hitting the graph in two places. Once at around 75, and once at 100. So when this x value is 0.5, we have to ask ourselves, is it 75? Is it 100? Is it both? What's going on here? And this is where that closed and open circle come in very handy. The closed circle means that's part of the graph. So this is the point 0.575, and that is part of the graph. This one, though, I have an open circle. An open circle means it's not part of the graph. So when x is 0.5, the y is 75. It's not 100. If I were to go to 0.6, okay, then y is 100. Or 0.55, y is 100. Or 0.51, y is 100. But at 0.5 itself, that's where the jump happens. And we have 0.5,75. So just to give you a little bit of a test on that to see if you understand, let's have a quick look at this area here. And I'm going to ask you the question, when x is 1.5, what is y? The correct answer is the closed circle, 125. It's not 150 because that circle is open. A couple common examples of where step functions actually get used, because they are actually really common in day-to-day life. Most common one is hiring a tradesperson, an electrician, a plumber, a roofer, whatever it might be, and they charge an hourly rate, but you pay the same amount for any amount of time within that hour. So whether you hire the tradesperson for an hour and 3 minutes, or an hour and 59 minutes, they're going to charge you for 2 hours. They don't charge by the minute or by the second. They just say $100 every hour. So 1 hour is $100, but anything over that, you're paying another amount, another $100. So each hour, we're jumping up to the next rate. And then it stays the same within that hour. Again, an hour and 1 minute, an hour and 30 minutes, an hour and 45, an hour and 59. You're all paying the same amount. Another example is a cab charges a rate for every whole or partial kilometer. So if you go anywhere between, let's say, 2 and 3 kilometers, you're going to be paying the same amount of money. But as soon as you go over 3 kilometers, the rate's going to go up. Have a go at worked example number 2. See if you can get that to make sense. Have a look at the example video, and then come back here when you're done so we can do that final type of graph. The last type of graph, maybe save the easiest for last. That's just a scatter plot. So the key features of a scatter plot, again, we've seen these before. Only certain x values make sense. So for example, decimals don't work. I can have 1 or 2 or 3 of something, but that's all. I can't have 1.5. This relates to discrete and continuous data. So if only certain values make sense, not every value, is that discrete or is that continuous? The correct answer is it's discrete. Scatter plot also is a series of disconnected points, and it may or may not follow a completely straight line. So it might look a little something like that. Some common examples where we might use this, and where it may not be a completely straight line, where we're looking at the cost of every individual item bought, so each donut or each pencil, and often what you might find is these frequent buyer cards. So buy 5, get 1 free. Well, it doesn't make sense to buy 1.5 or 2.5, but every once in a while you get a bonus one, you get a free one. And we'll see in the next example what that looks like in practice. Work through this example, and then we'll come back here and just quickly wrap up. So to see if you were successful, can you make decisions about which type of graph to use, and can you solve worded problems related to step functions, scatter plots, and line segment graphs? Try your hand at the assigned questions and see how you go. Thank you.